Right, greetings, YouTube. Beautiful mind here. We have the following question that comes from section 1.1, question 35 from our College Algebra text. This is Pre-Calculus Essentials for Roger Waters. This is from our College Algebra 1 course. And this question asks us, here, let's go ahead and label it. Again, this comes from section 1.1, question 35. It says, without sketching the graph, find the x-intercepts and the y-intercepts of the graph of the equation. Right? So I know we're not looking at the graph, but you can still get a sense without graphing it, right? I don't have my tool. Oh, sorry. Okay. I just realized I need to do one other thing. Hit done here. Okay, there we go. So let's try this again. Greetings, YouTube. Beautiful mind here. And we have the following question from College Algebra 1. This comes from our text from section 1.1, question 35. This question says, without sketching the graph, find the x-intercepts and the y-intercepts of the graph of the equation. Right? And so, now let me, as a disclaimer, for college algebra, our purposes, it is expected that you already know how to factor. Right? So this is a special factoring case of factoring trinomial. It's a trinomial because we have three terms, right? Terms are things that we add and subtract. So we have three things that we're either adding or subtracting. So this is a trinomial. So this is a special case of, factoring. And this is also it's just one of the cases where the leading coefficient is not one. I mean, is one. Sorry, the leading coefficient is one. So with something like this, even before we go into factoring and things of that nature, we can get a sense of what's going on without looking at the graph. We notice the highest exponent, the highest degree is 2, which means that we should be dealing with like a U-shaped graph. The leading coefficient is positive, and our y-intercept here is negative. So it's going to cross the y-axis below the x-axis, right? We have a negative y-intercept and a U-shaped graph that opens up. So if it crosses the y-axis on the negative side and the U-shaped graph opens up, that means it should cross the x-axis at least twice, right? So the first way that we have to find intercepts is basically set the corresponding component to 0. For instance, if we want to find the x-intercepts, we set y to 0. If we want to find the y-intercepts, we set x to 0. Now, personally, when I'm doing these, I prefer to do the y-intercepts first because oftentimes they're easier, right? When you set x to 0, that's a lot of times that's a lot easier to crunch than the other one. So we're going to start with the y-intercepts. We'll go with this color. Okay. So for the y-intercept, right? Again, what we do is to find a y-intercept, we set x equal to 0 and then solve, right? So to find the y-intercept here, we're going to say y equals, now we're replacing the x's with 0. So we're going to say x, first thing we're going to do is replace each x with a blank set of parentheses. So we're going to say x squared minus 2x minus 15, right? And then inside the blank parentheses, we're going to put 0. So a 0 goes there and a 0 goes there, right? So now we just solve, and you'll see quickly, this term goes to 0, this term goes to 0, and all we're left with is our negative 15. Okay. So then our y-intercept, so then what this is saying is that when x is 0, y is negative 15. And remember, we already said that, right? So that's our y-intercept. We actually just got that by looking, there was a constant term. In other words, a term that didn't have a variable in our original equation. So that's the y-intercept. So then let's go ahead and talk about the x-intercept, right? The x-intercept is where the graph crosses the x-axis. So that's, to find that, we basically set y equal to 0 and solve. So to find the x-intercept, we set y equal to 0 and solve, right? So same thing, right? If we're gonna replace every y with 0, so this one, I'm just gonna do it like this. I'm gonna say x squared minus 2x minus 15 equals 0. Okay. So then now we're into the special factor. I feel like it's a good habit to just go ahead. So you have, remember, this is in the form ax squared plus bx plus c equal to 0. So I feel like it's a good habit to go ahead and identify your a, your b, and your c, right? So in our case, our a is 1, our b is -2, and our c is -15. And so I feel like it's a good habit to just automatically go ahead and multiply the a times the c. Now, in this case, that's a bit overkill but there are going to be cases when the leading coefficient is not going to be a 1. It might be a 2 or 4 or whatever. It might be something there. But if you make it a habit of going ahead and saying your a times your c, you'll be working with the proper number. But if we said our a times our c in this case, we're looking for two numbers that multiply to give us -15, again, because 1 times -15 is still -15. Two numbers that multiply to give us -15 and add to give us -2, right? So I call that the AC method of factoring. So whenever I have a trinomial, like a quadratic like this, where the highest degree is 2, if I say my a times my c, in this case, I get -15. Look for two numbers that multiply to give me -15 and add to give me -2, right? So I'm going to go through all the combinations of the factors of -15 and stop at the line where they add up to 2, right? Now, what times what gives me -15? What is that, 3 and 5? So we don't have that many. 3 times 5. So now I'm going to go through all the factors. So first I have 1, and that's going to be times 15. But that adds up to -1 plus 15 is 14. So those are not the two numbers that we're looking for. So then notice we can't do 2. 2 is not in this list, but we can do 3. There's a 3 right there. So then if we do -3, then what, 5? Now notice that these add up to +2. We want -2, all right? And let's do like this. We want -2. So all we do is just move the sign around. So we're going to say 3 and -5. These add up to -2, and these are the two numbers that we were looking for, right? So then let's get a copy of this guy. So if we kind of go back here, I can work here. So if we kind of start over, right? So now at this point, we should be able to break this trinomial up into a form like this, all right? So we're going to break the trinomial up into the product of two binomials, all right? Okay, so we have our x and our x. The two numbers we just found were what? 3. So it was +3 and -5. Now, I know for this example, that seems a bit much, but the way that I'm doing it now is going to apply to more types of examples. There are faster, more simple ways to do it when this leading coefficient is a 1, but I'm just showing you this because when this is not a 1, this is the way you're going to do it. Or this is the way I would suggest. There's still other ways to do it other than what I'm doing. So I'm just showing you one way that works. It's up to you to find something else that's more simple that you resonate more with. But I'm just showing you that it's possible, right? So now, before we go forward, at this point, this is a good time to check. We just want to make sure that this matches this, right? So to check, you would FOIL. If you said first times first, you get your x squared. And then your outer times your outer is -5x. And then it's going to be inner times inner is going to be +3x. You add those together, you're going to get your -2x. And then 3 times -5 is -15, right? So if you FOIL this out, first, outer, inner, last, you get this line here, right? So we're good to go. So now here, because we have 2 or more things that multiply to give us 0, then that's called the zero factor property. And basically, when you have 2 or more things that multiply to give you 0, you set each thing to 0 and you solve, right? So If we set each factor to 0 and solve, we're going to have x plus 3 equals 0 or x minus 5 equals 0. And if you solve each corresponding equation, subtract 3 on both sides, x equals negative 3. Add 5 on both sides, x equals 5. All right. So then our x-intercepts, they're going to be negative 3, comma. I'm going to write the ordered pair right now, but you just want to put it in whatever form Pearson is asking for. Sometimes they want it like this. Sometimes they just want the negative 3 and the 5. All right, but these are the 2 points where that graph will cross the x-axis. Okay. So let's go like, and that's essentially the whole thing. Right? Okay. So hopefully that made sense. All right. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.